Hello everyone. I'm Shota Shirasaka from Fukuoka Institute of Technology. Today I will share our work. Comparison of pose estimation models toward nonverbal feedback for pre-service teachers. Thank you for joining our FOE 2026 virtual poster presentation. In classroom teaching, small movements matter. Where a teacher faces, when the body is hidden, and whether feedback can run on available hardware. With Dr. Imagawa and Dr. Enokida, we compare four pose estimation models for pre-service teacher education. This is exploratory and practice-based. The question is simple. Which pose estimation setup remains useful for classroom feedback under occlusion, back-facing intervals, and deployment constraints? We used 27 micro-teaching videos. The main stressors were lecture occlusion and back-facing intervals. So our goal is not a benchmark winner. It is a practical model choice for a classroom setting. This is why the comparison is shaped in three ways. First, it is not a leaderboard. Every model sees the same video and stressors. Second, it is not just a speed test. The detector can change throughput. Third, it is not always a full body problem. The lectern often hidden low body key points. The promise is choose four constraints. The setup follows the pipeline, shown here. We start with the same videos. We compare four pose models and use stability proxies as the final stage. The models cover different families. Bit pose base as a transformer model. RTM pose medium as a two-stage CNN model. Euro V8 medium pose as a single-stage option. And media pipe as a mobile and CPU option. Now we move to stability. This figure compares detection rate, mean confidence, jitter, and missing rate. The main pattern is clear. RTM pose medium has the highest detection rate. Bit pose base is the most stable in our data. Euro V8 medium pose is the faster pose option. Media pipe is feasible on CPU, but less stable. Friedman P is less than 0.001. Next, we stress the models with back-facing intervals. Each panel has three bars: detection rate drop, confidence drop, and jitter degradation. Bit pose base loses the least in detection. Euro V8 medium pose and media pipe lose more under back-facing intervals. Jitter degrades for every model. So orientation is not a small detail. It changes the reliability of feedback. The speed result adds a useful point. Each model appears twice: a circle with RTM dead and a square with Euro V8 nano. When we swap the detector to Euro V8 nano, every model becomes plus 26 to 41% faster. Detection rate stays almost the same in our classroom data. So, in this setting, we gain real speed with no accuracy loss. The last result looks inside the body. Darker cells mean more reliable key points. When the rectangle hides the lower body, a clear pattern emerges. Upper body points: head, shoulder, elbow, wrist stay mostly usable, but ankle fall to near zero across all four models. So this is a classroom condition, not a model error. So the practical message is conditional. If orientation and bold writing matter most, Bitpose base is a stable choice, but it is heavy. For balanced offline analysis, RTM Pose Medium with Euro V8 Nano is a strong option. For GPU-free deployment, Media Pipe is feasible, with lower stability. For speed-fast screening, Euro V8 Medium Pose is useful, but orientation sensitive. Thank you for your attention. We welcome your questions through the FOE networking area. We'll be happy to discuss the work further.